Hi guys, so today we're going to be doing homogeneous equations. So these are the two equations that we're going to be doing. If you have any questions, I'm going to leave my contact details so that you can contact me. So let's move straight to the first question. So the first question says solve the following equation. So if you look at this equation, you can see that this equation is a homogeneous. So how do you know if it's a homogeneous equation? So first thing first, you need to find dy over dx. As you can see, here you cannot do a direct integration. The reason why you cannot do a direct integration is because if you look at this equation, inside this dy over dx, it's a mixed function. What I mean when I say it's a mixed functions, because you have got the x and the y values in one bracket. So I cannot do a direct integration if it's like that. So you have to do a homogeneous equation. And then how do you check if it's a homogeneous? So homogeneous equation, you check your exponent. So you check which one is your highest degree or the highest exponent. So as you can see, the highest exponent is x squared or y squared. So between the two, you need to check which one is the highest exponent between x and y. So as you can see, the highest exponent is x squared. So you check for both x and y. So highest exponent is x squared. So as you can see, this one it's also the same as having exponent 2, because x is to the power 1 and then y is to the power 1 as well. So if you combine these two, you're gonna get squared if you add the exponents. So that's how you do it. Then the next thing to do is, you know that in order for you to have a homogeneous, you need dy over dx is equals to, it's either it's p xy over q xy, but they need to have the same degree. Like your highest exponent must be the same. So x squared, y squared, then also this ones I showed you that it's to the power 2 when you combine them. Okay, that's how you check. If they are not the same, then it's not a homogeneous. So let's write it in this format. So you can have dy over dx is equals to, so here you're gonna divide by dx to remove that dx there, and then obviously you're gonna have to take this value to this side. So you're gonna end up with xy over x squared minus y squared. Okay, so this is a homogeneous. You check your exponent, your highest exponent. So as you can see, your numerator and the denominator, they've got the same degree or the same exponent. Okay, so for homogeneous, the first thing that you do, you need to say let y is equal to vx. That's homogeneous. So you're gonna let your y is equal to vx. So whenever you see y, you're gonna substitute vx. Then after doing this, you differentiate. So it will always be like this. For homogeneous equation, you're gonna always let y is equal to vx. And then from there you differentiate. You find dy over dx. So when you find dy over dx, you're gonna get v plus dx over, sorry, dv over dx. dv over dx, and then times x. Okay, so we're gonna go back to the original equation and substitute this dy over dx. So you're gonna put v plus x dv over dx equals to x into, where there is y, you put vx, divided by x squared minus v squared x squared. So you square both of them. Okay, then here you're gonna say v plus x dv over dx equals to vx squared over x squared minus v squared x squared. Then on this equation, you're going to take out the common factor. So your common factor is x squared. So we're going to say x squared into v divided by x squared, open bracket, 1 minus v squared. Okay, then as you can see, everything is going to cancel. The x squared is going to go away. You're going to be left with v over 1 minus v squared. 1 minus v squared. Okay, so let's move to the next step. So the next step is to say x dv over dx. And then you take this v, to the other side of the equation. So you're going to have v over 1 minus v squared minus v. And then let's solve the right hand side. So the equation that I'm solving now is this one. Okay. So you're going to have x dv over dx equals to v minus, so look what I'm gonna do now. So you're gonna take this times everything that is there. That's how you do it. So you're gonna have v minus v. So you're gonna say minus v times 1, you're gonna get minus v. Minus v times minus v squared. Then you're gonna get minus, so it's a plus v cubed divided by 1 minus v squared. Okay, then obviously this and this you're gonna cancel, so you're gonna be left with x dv over dx equals to equals to v cubed divided by 1 minus v squared. Okay, so now you've got the functions of v that side, then meaning you have to make something like this: dv and the functions of v equals to integration of dx and the function of x. You have to make it like that. So remember, you cannot say 1 over dv or v over dv. No, the format of integration, you need dv at the top. Your dv must be your numerator, so you cannot have dv as your denominator. So you have to write it like this. At least if it's like that, dv over v, it's the right format. So this must be your numerator all the time. Okay, so let's group the like terms. So we're gonna group the functions of v with dv. So as you can see, we want this dx to be a numerator. So the only way to make it a numerator is to take it to the side. So we're gonna have dx and v cubed divided by 1 minus v squared. Okay, then this side you're gonna be left with x dv. Then now we can group the like terms. So you see, dv is a numerator and dx is a numerator. So that's what we wanted. So you're gonna say we take the x to the other side, then we say dv into 1 minus v squared divided by v cubed. When you multiply both sides by the reciprocal of that, by the reciprocal of this, to cancel, you'll have this. Then you'll say equals to dx divided by x. Then from here you introduce the integral sign on both sides. Okay, you introduce the integral sign. So remember, the integration of 1 over x dx, integration of this, you're gonna get ln x. So the right hand side will be equals to ln x. but the left hand side you have to split it. So you have to say 1 over v cubed minus v squared over v cubed. And then you put dv there is equals to, this one is solved already. Please note that the right hand side, whenever you see x values or x functions, that's when you put the plus c. So plus c, you only put it on the x side. Okay, so you can write plus c there. So let's proceed and solve the left hand side. So the left hand side, you're gonna have 1 over v cubed. There's nothing you can do on that one. Okay, so let's change it to like this, to exponential form. So we change it from fraction to exponential form. Okay, you're gonna say minus, dividing the powers of the same base, you subtract the exponent. So you're gonna be left with 1 over v, and then dv equals to ln x plus c. Okay, then the left hand side will be equals to, remember when you do integration, whenever you do integration always adds up. It will add you to the exponent, it will add 1. So it's like this. Let me show you. Take you back to integration, the basics of integration. So if let's say you've got ax to the power n, ax to the power n will be equals to ax to the power n plus 1 over n plus 1. This is the formula for standard integration. So that's exactly what we're gonna do there. So we're gonna have v to the power minus 3 plus 1 divided by minus 3 plus 1. And then minus, remember 1 over v, it's like 1 over x. Integration of 1 over x is equals to ln v is equals to ln x plus c. Okay, so let's move to the next step. So your answer for this will be equals to minus 1 over 2 v squared. That one. So here you're gonna get minus 2. Okay, then minus ln v, then equals to ln x plus c. And remember, y is equals to vx. So we have to solve for v. What is v? So v will be equals to, v is equals to y over x. So you can substitute that. Y over x all squared minus ln y is equals to ln x plus c. So you can leave your answer as it is. You can leave your answer like this. It's fine. Okay, let's proceed to the next equation. So the next question is also homogeneous. Then let's confirm that it's a homogeneous. We first check. Look at this. What is your highest degree? Your highest degree is this one and this one. So the highest exponent is x cubed, or let's just say it's cubed. Cubed is our highest degree of exponent for x and y, for both. So let's check. Is this one the same also? Okay, as you can see, you've got x to the power 1 and you've got y to the power 2. If you add the exponents of this mixed function x and y, you'll get cubed. So meaning it's a homogeneous. It's a homogeneous as well. So if it's a homogeneous, first you have to write it in this format. dy over dx is equals to pxy over qxy. Okay, then you have to say y is equal to vx always. Then this won't change, it will always be like this. So you have to memorize it. You have to memorize this. It won't change, it will always be like this. If it's a homogeneous, you first let y is equals to vx, then you say dy over dx is equals to v plus v plus x dv over dx. Okay, so let's go and write our formula in a standard form. So you're gonna have to say equate this to 0. Obviously you're gonna have to, there's equal sign there. So you have to equate it to 0. You have to equate it to 0. This is equals to 0. So you're gonna say dy over dx to the other side. So you're gonna be left with minus 3x y squared dy is equals to minus x cubed plus y cubed dx. Then dy over dx will be equals to minus x cubed plus y cubed divided by minus 3x y squared. Minus and minus are going to cancel. Then you're going to be left with this. So you have to substitute. It will be v plus x dv over dx equals to x cubed plus v cubed x cubed divided by 3x into v squared x squared. Okay, then let's proceed. You're gonna have v plus x dv over dx equals to, then you take out the common factor. So at the top the common factor is x cubed, and also even your denominator you'll have x cubed as a common factor there, because when you say 3x v squared times v cubed x squared, when you combine this you're gonna have x cubed. So you'll have x cubed as a common factor, 1 plus v cubed divided by x cubed into 3 v squared. So the right hand side will be equals to x cubed and x cubed will cancel, then it will be equals to 1 plus v cubed divided by 3v squared. 3v squared. Then from here you have to take this v to the right hand side. So you put that v there. Let's continue on the next slide. So you have x dv over dx equals to 1 plus v cubed over 3v squared, then minus v. So remember on the previous session I said you take this and you multiply it with that. So you will have, it will be equals to 1 plus v cubed minus 3v cubed divided by 3v squared. This will be equals to, you subtract the like terms, this and this, you'll have 1 minus 2v, 1 minus 2v cubed divided by 3v squared. Then now there's nothing you can do. You group the like terms. So you'll have x dv is equals to dx into 1 minus 2v cubed divided by 3v squared. Then you take this to the other side. So when you take it to the other side, you'll have dv open bracket 3v squared over 1 minus 2v cubed equals to dx over x. And then let's take the left hand side first. So the left hand side, as you can see, the left hand side is a bit tricky. This one is a bit tricky, so we're gonna solve it separately. The right hand side will be equals to, when you introduce the integral sign on both sides. So now when there is nothing to simplify, you just introduce the integral sign on both sides. So the right hand side will be equals to ln x. Remember, you'll have integration of 1 over x dx, which is equals to ln x. So let's go and solve the left hand side separately. So you'll have integration of 3b squared over 1 minus 2v cubed dv. So look at this. As you can see, the top, you compare, whenever you see this, a fraction in integration, you have to compare your numerator and the denominator. One of them must be the differentiation of the other. So remember, there is a formula that is like this: f prime of x over f of x dx is equals to ln f of x. They don't show this, but you have to multiply by 1 over f prime of x plus c. So they mean that the bottom one must be your f of x. Then when you take that f of x and differentiate it, it must give you the top one. You must get the f prime. So let's go and take the bottom f of x, which is 1 minus 2v cubed. Let's differentiate that. So when you differentiate that, you're gonna get minus 6v squared. Do you see that this, you can write it as minus 3 into, okay, you can write it the same way. You'll get the top one either way. So you'll get 2. So the numbers don't matter, the coefficient of this don't matter. So the main thing that you want is this function. So you'll say minus 3v squared. Do you see that is the same as the top one? So if this is the same, then you can use that formula. So what I normally do is, the numbers don't really matter. The most important thing that matters is this: v squared and v squared. You see, v squared and v squared, because the numbers will always divide. So you need to consider that. So we're gonna go back to the equation. So when you go back to the equation, since you confirm that it's using this formula, so let me show you something. I know that it's ln f of x, my answer, but you have to multiply it by 1 over f prime that you got, the new f prime. This f prime is always that one right there. So you take the f prime from the original equation, because they must cancel. So you keep the original f prime there at the top. So you're gonna have the original f prime, which is 3v squared. So they must cancel to confirm that your answer is correct. You always keep it there. Keep it there, the original. On the equation, you just put the original f prime there. This will help you to ensure that this and this must cancel. So if they don't cancel, it's wrong. So you're gonna say ln f of x. What is my f of x? F of x is 1 minus 2v cubed times 1 over f prime. The f prime that I got, the new one, new f prime. So they normally say let f of x is equals to u. So you can use the u method here. Yeah, if you want to, you can use that. So let's just write minus 6v squared. So now you're gonna divide the like terms. So this can be written as 3v squared over minus 6v squared. You see the reason why I said the numbers don't really matter. What matters is this: they must cancel. The numbers will always divide. See? So now the answer that you're gonna get there, you're gonna get 3 over minus 6. What is 3 over minus 6? So 3 over minus 6, you're gonna get minus half ln 1 minus 2v cubed. So this will be your answer for integration of 3v squared over 1 minus 2v cubed dv. Okay, so and then from there you're just gonna confirm, just gonna combine them. You're just gonna combine them. So here what I mean is your final answer. So your final answer will be plus ln x plus c. This will be your final answer. Obviously you have to say y is equals to vx. You substitute the value of v. That's all. That's how you do it. So thank you for watching, guys. If you do have any question, please let me know. I'll leave my contact details on the description. And then every Tuesday at 7:30 we'll have a session, online session on our YouTube channel. Please don't hesitate to ask any question. Thank you.